All right, here we go, guys. I need to make sure it's recording. Okay, yeah, we're recording. Okay, so here we go now, please follow along. All right, speak up when you don't know something. All right, we're getting a little bit more advanced now with the equations. This is something new. Not the first couple, but we're getting into some tougher equations that's super important for next year. All right, remember, showing your work, quality, honesty, those are the things I need you to tell me, all right? And work all the problems, show all your work. How do we do undo plus 4? We subtract 4. And so now the positive 4, the negative 4 cancel out. So x is equal to negative 13. All right. Hold on, it looks like we have somebody trying to enter. All right, don't worry about the chats now, guys. All right, I'll make all that clear. Okay, don't worry about a test. All right, back to work. All right, sorry about that. Question number 2. All right, we're dividing by negative 4. So to undo dividing by negative 4, we multiply both sides by negative 4. And the reason we do that again is those cancel. So x equals 32. I know that's not anything new for you guys. All right, over here, we're just practicing our fractions. We subtract 1/2.
Mr. Stroh,
Yeah.
for number 2, or I know for number 4, I cross multiplied and I got that. So is it okay if I just cross multiply?
Yeah, you can cross multiply. But the main thing, remember, is I want you to understand this means dividing by negative 4.
Yeah.
All right. So if you divide by negative 4, you can undo that by multiplying by negative 4. If you made it a proportion, cross multiply, divide, same answer. Okay?
Yeah.
Now let's look at question number 6. All right, now it's just reviewing how do I do fractions. All right, so we got to get a common denominator. 1/5 is the same as 2/10 minus 5/10. So negative 3/10. Now's the time where you really got to speak up if you're not sure about something. Any issues?
I don't get that one.
What's that?
I don't get that one.
So this is just getting a common denominator. So the common denominator with 5 and 2 is 10. So in other words, you're multiplying the first fraction by 2/2 and the second fraction by 5/5. Does that make sense now, Marin? Hey, Marin?
You okay?
Yeah,
sorry, I was muted.
That's okay. You good now?
Yeah, thank
All
you.
Right. You're welcome. Okay, let's check out number 8. Again, number 8 is dividing by 4. So you multiply both sides by 4. Now x equals, now remember, you can say this is the same as 4/1. And now you're multiplying because nothing reduces. So your answer is just 8/3. All right, again, simple little review of fractions.
Mr. Stroh?
Yep.
Wouldn't that be a proportion?
You can do it as a proportion, yes.
Okay, because I got 24.
No, for the proportion, look. If you decided to do it as a proportion, you would be multiplying this, and then you would be multiplying this.
Oh, okay.
So you can see it get the same answer. Divide by 3, divide by 3. So 8/3. Okay?
Thank you.
All right. Now, let's take a look at number 10. Now, for number 10, all right, what I want you guys to realize is basically I'm trying to get the variables on one side of the equation and the numbers on the other side. All right, now what do I mean by that? This is the left side, and this is the right side. Now, left and right of what? Left and right of the equal sign. You with me? So all the variables have to go on the left and all the numbers have to go on the right. Or we can say, we can put the numbers on the left and the variables on the right, whichever way is easier, okay? So the equal sign is the middle. So we say, this is the left and this is the right, okay? Now, why am I bringing that up? Because in this problem here, the 9x and the 3 have to be separated. So the easiest thing to do would be to subtract 3 from both sides. All right, and then this would give me 9x, and this would be negative 18. And now we simply divide both sides by 9, and we get negative 2 equals x, but of course we always put our variable first. So we say x equals negative 2. Okay, now's the time to speak up, please. Anybody has any questions? Anybody have any issues? Okay, so let's go to the next one. All right. Now, number 12. All right, this one's just reviewing decimals. So we're going to add 1.5. We're going to add 1.5. 2x equals, now we're subtracting. So negative 5.2. And then after we're there, all right, we're going to take and divide both sides by 2. So x is equal to negative 2.6. All right, Harrison made it. Hey, Harrison. You up yet, Harrison? All right. So that was number 12. Does anybody have any question with number 12? All right, let's go to 13. Now, 13 is an important one, so I need everybody to put a little star by it. When you look at it, you should say x.
Not true.
Right, x equals x plus 1. How is that possible that a number equals itself and it equals itself plus 1? We say that's a contradiction. That cannot happen. All right, so in math, if something is a contradiction and cannot happen, we say there is no solution. Right, that's the symbol. All right, for no solution. Now somebody might say, well, I didn't really see that. All right, so I'm going to show you now how you can look at that. And if you do the math, you can tell it's no solution. Because watch, if I subtract x, I now have 0 equals 1. And there's the contradiction. 0 cannot equal 1. Therefore, the equation has no solution. All right? No x value will satisfy that condition. All right? Anybody have a question with that before I go on? All right, now the next one I want to talk about is I'm going to make up a problem. All right, and I want everybody to review this. All right, I want everybody to write down, let's say, for example, I said 2x minus 6 was equal to 2x minus 6. Well, you should be able to look at that and say, that's a little strange. When does 2x minus 6 equal 2x minus 6? We say this is an identity. And so we could say x is all real numbers. So it doesn't matter what number we plug in for x, the left side will always equal the right side. 2x minus 6 is always equal to 2x minus 6. That's why we call this as an identity, and it is in fact all real numbers. All right. Now the question is, how would you know if you weren't thinking about it? How would you be able to look at that and see if you missed it? Well, you would be solving the equation, and then you would realize what happened. Everything canceled out. So it'd be 0 equals 0. And when does 0 equal 0? Always. All right. That's why we say it's all real numbers. Okay. Anybody have any questions? All right. So let's check out number 16. All right. Now, remember, for question number 16, if we wanted to, we could distribute the 4, but I notice that if I divide by 4 and I divide by 4, since negative 28 is divisible by 4, I can just go ahead and do the division first. So this would be 2x minus 5 equals negative 7. Then from there, I would add 5. And then I would have 2x equals negative 2. Divide both sides by 2. And so x equals negative 1. All right, does anybody have any questions? Anybody have any questions?
Mr. Stroud,
Yes, ma'am.
for that one, how do you know that the 5 is a negative, not a subtraction?
Well, you learned something very important. What is that symbol right there?
A subtraction sign.
Okay, what if I did this? What is it now?
The negative.
Now what is it?
A negative. Oh, no.
We'll read that. Right. So what's the difference between a minus sign and a negative sign? The answer is nothing. Okay.
Yeah, it's nothing.
Right. This right here, hold on one second. This right here is the symbol for minus and negative. All right. You with me on this now?
How do you know what one to use, though?
Well, it doesn't, it's the same. It's just called something different. Right? Minus and negative is exactly the same thing. There's no difference.
Well, what if you had to actually multiply x and 5, but you thought it was minus? Do you know if it was a negative or not?
Well, that's what I'm telling you. Is this minus 5 or negative 5?
I don't know.
It's whatever you want it to be. That's right. It's the same. Minus 5 and negative 5 are exactly the same. There's no difference. Okay? So don't be confused. Your job is to work backwards. So when you read this right here, you read it as 2x minus 5 equals negative 7. Right? But you could also say that is a negative 5. So to undo a negative 5, I add 5 to both sides. Okay?
Okay.
All right? And let's practice, okay? Let's just make sure you understand what I'm saying.
Mr.
Right.
Sprout,
Yes, I'm listening.
could you also do distributive property?
Yeah, let's do that. Let me show you. Let's just say, for example, it didn't occur to you to divide, let's say it just didn't occur to you to divide first. So what I want to do is I want to show you it's the same answer. 4 times 2x minus 5. Now when you distribute, that becomes 8x. That becomes negative 20 or minus 20. And then what? We add 20 to both sides. So we have 8x equals negative 8. Then we divide by 8. So x equals negative 1.
Okay.
Same thing. All right?
Thank you.
Good job, kiddo. All right, now we've got some more fractions. All right, so everyone, make sure you're working this out. 4 times 1/2 x is 2x. 4 times negative 6 is negative 24 equals. Now we're going to do 2/3 times 6, which is the same as 4x. And 2/3 times negative 36 is negative 24. Now, if you need help with the fractions, just say it and I'll review with you. Does anybody need me to review the multiplying those fractions?
Well, when you multiply 4 times 1/2, don't you have to change it to, wait. I thought for some reason you had to change it to 2/1.
No, that's if you're solving the equation. All right, so let me give you what you're thinking of. If I said 1/2 x equals 8, you would multiply by the reciprocal. You with me? But we're
Yeah,
not solving that equation. We're distributing, okay?
How did you get 4 from 2/3 times 6?
Okay, so let's just review. 2/3 times 6. One way is just say, what's 2 times 6?
12.
And then divided by 3.
4. Oh.
Right, but to me, I always tell kids do the division first. 6 divided by 3
2.
times 2.
4. Okay.
So 36 divided by 3 is 12. And then 12 times 2 is 24.
Okay.
All right?
Yeah.
So now we're back to moving variables to the left. So I'm going to move the 4x and put minus 4x. And then I'm going to add 24 and add 24. Again, the reason we're doing that is because, right? Now, yeah, everything canceled out here. So in this case, it just became negative 2x is equal to 0. And then we divide both sides by negative 2. And 0 divided by anything is always 0. So x equals 0. Anybody have any issues with that?
Where'd you get the -4?
Okay, so let's go back here for a second so I can show you. So I always want to move my variables together. So I need to put the 4x over on this side. So if I move something, I change the sign. So this is negative 4x. Is that helpful, Aiden?
Kind of. So if 5 was there instead of 4, it would be -5 on both
Right,
sides.
exactly.
Okay. It's
Okay.
just a larger number.
No, it doesn't have anything to do with the large number. Remember, it has everything to do with variables on one side and numbers on the other. I'm always trying to move the variables to the left side, and this goes to the right side. So over here, it was a minus 24. So on the right side, it would be a plus 24. Okay?
Okay. So it's just okay.
All right, so let's check out number 20 now. So on number 20, all right, I want everybody to distribute. So when you distribute the 4, you end up with 12x minus 28 plus 10 equals 12x minus 18. All right, now you want to check to see if you can combine anything. what is negative 28 plus 10? So that gives me 12x minus 18 equals 12x minus 18. Now, what did I say earlier in the unit? All right, this 12x minus 18 always equals 12x minus 18. So we say this is all real numbers because it is an identity. All right. Now speak up if you don't know what I mean by 12x minus 18 equals 12x minus 18. You should recognize that.
I thought since there's parentheses around the 3x minus 7, which is now 12x minus 28, I thought you couldn't just do plus 10 without doing what's in the parentheses like first.
We did what was inside the parentheses first. Let me demonstrate that.
Oh, we distributed.
Yes, we distributed.
Okay.
All right, and then we combined the terms. All right. Anybody have any questions on number 20? All right, here we go. All right, let's look at 22 now. All right.
I don't understand number 20 because like when you why did we move everything around?
So what I want to do, Harrison, I want to look at this right here. The only thing I moved, really, I want you to think about this for a second, is I want you to tell me what's negative 28 plus 10.
Negative 14
You mean negative 18?
or negative 18.
Right, so I left the 12x alone. I combined these terms. That's all I did.
Mr. Stroud, does that mean there's no way to solve it then?
Well, that means any number. Okay, so let me say this one more time. I want everybody to listen. Stop writing and listen. What this means is that the left side always equals the right side, no matter what. The left side always equals the right side, no matter what number you plug in. Now I'm going to scroll back for a second, so I want everybody to hear me. What number up here makes the left side equal to the right side? Somebody tell me. When does the left side equal the right side? Someone tell me.
X.
When x equals what?
0.
Yes, guys, come on. The only time the equations are equal is if x equals 0. Now I want to look at this one, number 20. When does the left side equal the right side? Come on, guys. When does the left side equal the right side? I'm giving you a hint.
Zero.
I'm giving you a hint. When does the left side equal the right side?
When the
0.
Always.
Always. Yes, always.
Right?
Yeah,
No matter what
always.
number you plug in for x, if you do this and do this, they will be equal. That's why we say it's all real numbers. Now, for question number 16, when does the left side equal the right side?
Always.
No, not for number 16. When does the left side, say it, Michaela.
When the variable is -1.
Yay, exactly. Now you understand me. If x equals -1, the left side is equal to the right side. What if I said x equals 2? Is this equation going to be true?
No.
No, it is not. There's only one time in which only one number allows that equation to be true, and that is when x equals what? -1. Over here, the only time it's going to work is when x equals what? 0. Here, no matter what number you pick, it's always going to be equal. All right? So let's check out 21 now, or 22. All right? So on number 22, I need you to make yourself a special note. This is a -1. So I want to distribute the -1. So I want 6x minus x minus 3 equals 3x. How's that going? Everybody okay with that? Now we have to combine. Now we're going to combine terms. 6x and -1x. 5x minus 3 equals 3x. Go ahead. Anybody have a question?
I don't understand how you can just change the 6 to a 5. Because
I didn't. You tell me what's 6x minus 1x. Right? No. Honestly, I don't. You guys are learning. All right. This is much harder than before. All right. There's lots of rules. That's why you got to pay attention and you got to ask me right away.
wait, why did you add the 1?
What do you mean? Why did I add the 1? I just said what's 6x minus 1x. What is it?
5x.
Yes. Right. That's how I got from 6x minus 1x to 5x. Do you agree with that or not?
I agree with that.
Okay. Now,
Mr. Stra-
I'm listening. Go ahead, Michaela.
how come you changed the +3 to -3?
Because I distributed negative,
Oh,
right?
right.
-1 times x, -1 times +3. That's what I'm telling. Everybody's got to speak up.
Mr. Stroud,
Yep.
how do you tell when it's a -1 and when it's not a -1?
If there's no number in front and it's a minus, that means -1,
Okay.
right? Anything else, there'd be a number. If it was -2, it has to be -2, right? The number has to be there. 1 is special, all right? You don't have to write the 1, okay? All right. Now I'm trying to isolate the variables. I'm trying to put the variables with variables. So now please watch. I'm going to subtract 5x. Subtract 5x. So I get -3 equals -2x. I'm still isolating the variable, so I need to divide by -2, divide by -2. So x equals 3/2.
Why do you have to divide by -2 and not -3?
Well, because listen to me, that's another good question. You ready? You always divide by the number that's in front of the variable. You always divide because ultimately you're trying to solve for x, right? You want x to be by itself. So if I'm trying to figure out what x is, I have to get rid of the -2. You agree with that or not?
Yes, sir.
All righty, good job. All right, let's do 24 now. All right. Now, what I'm going to do is I got my little timer here. I'm going to give everybody a minute. All right. I want everybody, I'm starting my clock. I'm giving everybody a minute to try to do 24 to see how good you are. All right. If you've already done it, if you already did it, just erase it and do it again.
Okay.
1 minute. Here we go. Trying to put the clock up there so you can see. I'm giving you 1
Dang it, I
minute.
can't find it. Wait, what question is it?
24.
Okay.
Oh, I'm trying to fit there. 24. Now you can see. Clock's going. 20 seconds.
Oh, already? I've only done the first line.
Because you're talking.
What? Okay, I'll stop.
All right. Because Nate's whining, we're going to add 15 seconds.
Thank you.
Okie doke. Let's see how you did. All right. Now, again, to me, it doesn't matter about finishing. All right. What's important is that the steps that you're showing. All right. So please, all right, watch. Make sure this is what I want. 2 times 5x. We all know that's 10x. 2 times negative 9 is negative 18. Minus 7 equals 6x minus 12. All right, now what I'm going to do is I'm going to combine terms. Negative 7 and negative 18. All right, so I have now 10x minus 25, because I'm combining terms, equals 6x minus 12. All right, is everybody happy with that? Anybody have any questions on that step? If you got that far, you're in really good shape. Now, finally, we're going to move our variables to the left and our numbers to the right. So I'm subtracting 6x, subtracting 6x, adding 25, adding 25. All right, so now I have 4x equals 13. Now, divide both sides by 4, divide both sides by 4. So I have x equals the fraction 13 over 4.
I got that.
All right. Now, like I said, if you know how to do that, you are way ahead of the game now. All right, you're doing an excellent job. Okay.
Excuse me, Mr. Snow.
And speak up though if you're a little behind.
Okay.
All right.
Mr.
So
Stroh,
I'm listening.
I don't get why you wouldn't divide 6x instead of subtract it.
Okay, so the only time you're going to divide is if the variable has been combined to make one variable. So the first thing we have to do is I have to move this 6x over with the 10x. It's like you're combining terms. That's why.
Okay.
All right. James, what about you, buddy?
Can you go back to number 22? I didn't completely really understand that.
Say that again.
I didn't really understand number 22.
Okay, so we'll go back to 22 in a second. All right. Does anybody else need me to repeat number 24? Does everybody?
Yo,
Yes.
about number 24, so you did 6 minus 6, 0, and then...
Right, so these guys canceled.
Okay, and then...
The negative 25 and the 25 canceled. Go ahead, sorry.
Pretend if, like, it was, like, 7 minus 6, and that was 1, and then would you do 4 plus 1 to get your answer?
No, I'm just, you're basically, essentially what I'm trying to teach you is this. That you're just combining terms. 10x minus 6x is 4x. Just like negative 12 plus 25 is 13. You're combining terms. You don't multiply or divide until the very end. All right, I got a couple more problems we're going to do, okay? So be patient with me. I'm going to, now 26 is a little bit harder because it's got some fractions. But James had a question on 22. So let's look at that, James. All right. So I want you to look at it, James, and tell me where you got lost at, buddy.
Okay, I think I understand now.
You sure?
Thank you.
All right, you're welcome. All right, so now let's look at 26. All right, again, Same situation. I'm moving the variables to the left and the numbers to the right. So the minus 5, we have to do plus 5, plus 5. Now the 3/4 x needs to go over to the left side. So I have to do a minus 3/4 x minus 3/4 x. All right, now what I need someone to do is, if you're not sure about that right now, now's the time where you got to speak up and tell me you're not sure. Everybody okay with that?
About what?
So I'm looking at question number 26 right now, right? That's the initial step, what I just did. Now, I'm not saying you understand anything. I'm just saying, do you understand how I moved the numbers and I moved the variables? Anybody have any issues? All right, now what we're going to do is we're going to combine the terms. Okay, so this minus 5 and plus 5 cancels. The 3/4 and the negative 3/4 cancel. So now your job is to tell me what's 8 plus 5. Well, that's obviously 13. Now we got to practice our fractions. 2/5 minus 3/4. We don't need a calculator. Someone tell me what the common denominator is quickly. 20. So the first fraction, how many 20ths is that? The top fraction, how many 20ths is that?
8.
8, thank you. And the bottom fraction, how many 20ths?
15.
That is correct. So I'm now just doing 8 20ths minus 15 20ths. Everybody okay with that? So that's negative 7 20ths. All right, so this is negative 7 20ths x. Now you got to speak up if you're not sure. It's time to speak up.
Why did you make the 2/5 the 8/20ths and the 3/4 15/20ths?
Because remember, Harrison, when we're adding and subtracting fractions, we have to have a common denominator. Does that make sense now?
Yes.
I cannot add these fractions unless they have a common denominator. Anybody else? Anybody? Okay, so here we go. All right, now from there, we just multiply by the reciprocal. So the reciprocal is negative 20 over 7. So I'm multiplying by negative 20 over 7. Now again, the reason we do that is because these cancel. X is equal to positive times a negative is a negative. So now 20 times 13 is 260 over 7. How's that? Everybody good? Any questions? All right, I'm pretty happy with that. Okay,
Mr. Strout, I have a question.
good.
For negative 77 over 20, and how it equals 13, then, sorry, my dog's barking. I thought 13, because negative 7 plus 13 would already equal 20, right?
Hold on a second. I'm asking you this question. This is what I'm solving for, right?
Yes.
So these two things are held together with multiplication. Do you understand that?
Yes.
So to undo a fraction that's multiplied, we say we multiply by the reciprocal.
Okay, I just didn't understand why X is so big when really 13 plus 7 would equal 20.
No, we're not adding. You're not adding, though. You're multiplying.
I know.
You with me now, right?
Yeah.
Okay, good. All right. So here's everybody. This is what I need your attention on. Please listen carefully. All right. Everybody is supposed to have the odds worked out. All right. I did all of the odds on a video. So if you're not quite sure I think what I'm going to do is I'm going to look at your work and I'm going to kind of grade your work on numbers 30 through 46. And that's what I'm going to give you a grade on. Is everybody with me?
Wait, so do I only have to do 30 through 36?
No, you're doing the whole worksheet. You're doing the whole worksheet. The odds are supposed to be done. I'm not going to grade the odds. Well, I'm going to look at them to make sure you're doing your work. The ones that I'm looking at specifically for a grade are going to be 30 through 52. That's going to go in as like a quiz grade or a test grade. When you submit it, I'm going to grade it, and then I'm going to send it back to you if there's a problem, and then you can make the corrections. So again, remember the emphasis is not on grade or whether it's a test or a quiz. The emphasis is on, do you know how to do it? All right, and I'm going to judge if you know how to do it by looking at your work. And I'm expecting the work to be neat, all right? Show all of your steps. And then if there's a problem, I'm going to write you a note and you fix whatever the problem is. Is everybody okay with that?
Mr. Stroud?
What?
Mr. Stroud? Oh, sorry.
Go ahead.
Is the 30 through 52 evens?
Yes, that's what I'm going to be looking at. But the whole worksheet has to be done. Is everybody with me? Right? But I'm going to start at 30, and I'm going to grade 30 through 52. And I'm going to give you a grade on that. Neatness, your work, showing your work, those types of things. If you're having problems or you think you're having problems, you just have to let me know. Say, hey, I don't know how to do 48 or 40, whatever. And I'll try to get with you and show you how to do it. All right? I don't mind you guys helping each other, but I do care that you're showing all of your work and it's quality, not sloppy garbage. Does everybody hear me?
Mr.
Yeah. Does anybody have any questions before we go? Go ahead.
Yo, Mr. Stroud. Oh, sorry.
Take care.
You're
Who's asking me a question? Anybody? Nobody has it?
Are you grading us on the evens 30 through 52?
That's exactly what I just said.
Is it on? Wait, it's correctness, right?
What's that?
It's correctness, right?
Of course it is. I don't want slop.
Mr. Stroud,
Yes.
is that a real beach? It looks really real.
It is, man. I'm on the beach tanning.
Why didn't you bring me, bro?
Well, next time.
No, that's kind of.
Okay, next time.
Okay, and Mr. Stroud, this might take me a little while.
Yeah, so you're allowed to turn this in. Get it done. It doesn't have to be done today. All right, you have till next class period, but turn it in as quickly as you can.
Sure.
So if you get it turned in,
Yes, sir.
I can grade it and send it back. If there's corrections, you can correct it and send it back to me again. Everybody good?
Mm-hmm.
All right, you guys have a great rest of the day.
Mr. Stroud, I have one quick question.
Quick.
So for number 28, it's negative x, so it's not negative though, it's a positive number, right? Whatever the answer is.
So you're going to be dividing by -1. Don't forget there's a -1 in front.
Mr. Stroud.
Oh, really?
Yes, really. If you're ever unsure, just put a -1 in front.
Mr. Stroud, guess who's my new
No.
background at the beach?
Is that you? I think you just show up at the beach, Aiden.
You see?
I think I see you.
No. Like, you're my new background at the beach now.
Oh, stop, man. That's all right, guys. The end.
Wait,
Get
Mr.
your work
Stroud.
done. Who said
Bye,
that?
bro.
Me.
Bye.
Bye, my G.
When
Mr. Stroud,
when we're
Yes.
trying to solve it, do we
Yes.
just how do we like multiply with the fractions? Do we just how do we do that?
You multiply by the reciprocal.
Okay.
Now listen, if you haven't watched the video of the odds, my advice is to go back and watch the video of the odds.
Okay.
All right, buddy? And then let me
Got
know
it.
if you're having a problem. All right,
Okay.
you guys, be good. Stay safe. See you next time.
Mr. Stroh, does
You
this
said-
count as our test that was supposed to be on Friday?
Yes, yes, you get this turned in.
Also, I'm confused on number 28. Do I do -1 minus x plus 12 equals -2?
I have no idea what you're asking, but here you go. You watch. So on this one, kiddo, all you're doing is subtracting 12, right? Do you agree with that?
Oh,
Okay.
I did that, but then
Okay, hold on. So then you have negative x equals -14. Do you agree with that?
so
Wait a minute, I'm just asking you, do you agree with negative x equals -14?
yes.
So now we're going to, this is like -1. You can say divide by -1. So x equals 14.
Okay, thank you.
You're very welcome. All right. Take care, kiddos.